Good day, everyone. For today's lesson, we are going to tackle about the qualitative analysis of an ion and an ion. And we are also going to contrast the different methods of separating cation ions. First, we are going to have the meaning of qualitative analysis. So we all know that cation ions are the positive charges and the anions are the negative charges. So qualitative analysis is a structured set of methods used to determine the identities of the components that make up a mixture. It is also used to establish the presence or absence of a particular elements or inorganic ions that we found in a sample. You might be wondering why are we going to use the qualitative analysis instead of quantitative analysis. So we're going to use the qualitative analysis because qualitative analysis, it is just a descriptive form analysis. It is also going to identify and separate the cation ions and anions from the sample substance. So unlike from the quantitative analysis, which seek to determine the quantity or amount of a sample substance.
Since you already discussed the qualitative analysis, so now we're going to give the cation ions and the ions. The cation ions is the cation ions. These are the ions that has a positive charge. Like for example, the potassium plus, it could be Na or sodium plus. Then regarding about anions, these are the ions that compose of the negative charge of an element, like Cl negative, Ne negative, N negative. So how to get the positive charge of cation ions and the negative charge in ions to be formed in a neutral compound? Being mix of cation ions and ions can be called the ionic compounds. Mj of magnesium has 2 positive, while in ions, nitrogen, let's give 3 negative. To mix these two, we should cross multiply, or it could be, since it has a 2 positive and it has 3 negative, so it's not balanced. To get these cation ions into forming a neutral compound, we're gonna mix it MJ N. It means 2. It means we should put the 2 here and the 3. 2 times the 3 negative of nitrogen is equal to 6 negative, while 3 times the 2 positive of magnesium is equal to 6 positive. Then 6 positive minus 6 negative is equal to 0. So it's just a neutral compound. So this compound is namely a ionic compound, the combination of cation ions and ions. Now let us have other example on how to get or to separate cation ions and anions. Then we are going to have some aluminum. Aluminum has the oxidation number of positive 3, while chlorine has a oxidation number of negative 2. To neutralize these elements, or to get the cations and anions and to form a neutral compound that could be called ionic compound, we're going to put Al and Cl. So where we're going to put these 3 positive? So we're going to put here some 2 to have a positive 6. Right? 2 times the 3 oxidation number is equal to positive 6. Then here it has a negative 2. We're going to put some 3 subscript here to have a negative 6 oxidation number. And positive 6 and negative 6 is equal to 0. So we are now having the ionic compound.
A pleasant morning to each and everyone.
I am Kizzy Jane Sobrimonte.
And I am John Rico Hanoy. And I am Ivy Grace Flowers.
And we are going to discuss on naming ionic compounds. Alright, now I'll show you how to name ionic compounds. So first, you name your cations, which is usually metal, and then you name your anion, which is usually nonmetals. It could also be a polyatomic ion. So for binary ionic compounds, this is the one in which we have 2 different elements, so a metal and a nonmetal. In binary ionic compounds, the anion where the nonmetal ends with the suffix IDE, for example, bromide, chloride, oxide, and etc. So in group 1A metals, 2A metals, aluminum, zinc, silver, and scandium form only one type of cation. So in 1A metals, we have a +1 charge. In 2A metals, we have a 2+ charge. In aluminum, we have a 3+ charge. And for zinc, we have a 2+ charge. In silver, we have a +1 charge. And in scandium, we have a 3+ charge. So if your metal is any metal other than these metals that are listed here, then you're gonna need to use a Roman numeral to specify the charge of the cation from which the metal form belong. So let's go through a couple of examples. So another tip on trying to name an ionic compound is anytime for a metal that forms more than one type of cation, our Roman numeral in parentheses is used to show its charge. For example, Fe2+ and Fe3+. So, Fe2+, we can call it as iron 2 ion. And for Fe3+, we can call it as iron 3 ion. Because iron is a metal that can form more than one type of cation. So you may asking yourself, well, which metal can form more than one type of cation versus which metal can only form one type of cation? So we will discuss it later. So our example here is NaBr. So what is this stuff? What is the name of this? Well, looks like we have a sodium ion Na+. And then our anion is bromide ion Br minus. So the name of this compound is sodium bromide. Notice we don't have to use Roman numeral here because sodium is a group of A1 metal, so it only forms plus one cations. So Na, sodium, lithium, potassium, rubidium, cesium, and all of those metals only form the plus one cation, so a Roman numeral is unnecessary.
Okay, the charge of K ion. Then we will cancel out the 2 minus charge of oxide ion. So this compound is overall charge neutral. So we have the potassium ion, so we have the oxide ions. So the name of this compound is potassium oxide. Then again, the name of this compound is potassium oxide. Just like what we did to the sodium ion, the potassium ion doesn't need a Roman numeral because it also have a carbonic metal. Then, let's have another example. How about this one? So then again, we will have to get the cations first, which is the calcium ion, which has calcium 2 plus. Then we will have the anions, which is the fluoride ion, which is F minus. Since fluoride ion has a charge of 1 minus, then it has 2 fluoride, then we can cancel out the calcium ion, which has 2 charge, 2 plus charge, that makes the whole equation balance. So the name of this equation or compound is calcium fluoride, wherein the cation is the calcium and the anion is the fluoride. Pretty easy, right? Then let's have a harder one. Okay, now let's have this one. What is the name of Al2 parentheses SO4 of 3? What is the name of this? So then, our cation is aluminum ion, which is Al3 plus. Since aluminum is in the group 2A of metals, then as we can see in our previous topic, that aluminum is under the only one type of ion here. Since it is under in the only one type of cations, then the Roman numeral is only 1. That's why there is no charge in here. So let's move on to the cation, which is the SO4 or the sulfate ion. The formula of this is SO4 to negative. Since SO4 to negative has the 3 sulfate ion, then it can neutralize the aluminum ion, which has 3 charge of two aluminum ions. The trick part, or the best thing to do, is to memorize the formula of the sulfate, which is SO4 2 negative, which has the 2 negative of charge. Then the the compound has the neutralize, then it we can say that it is balanced. Then the name of this compound is aluminum sulfate, wherein the cation is the aluminum and the anion is the sulfate.
So now let's move on to my ideal tricky. FePO4. What is the name of this stuff? Well, as you might recall, iron is actually one of the metals that can form more than one type of cations. So when your metals form more than one type of cation, it's a good idea to start with an ion first and then see if you can figure out the charge of your cations from whatever the charge of your cation is. And so let's start with an ions. And an ions is this right here. This is called the phosphate ion. Phosphate ion is PO4 3 negative. Again, this is just one of the polyatomic ions that's worth to memorize. So given there is a phosphate ion has a charge of 3 minus, and we have only one iron for the iron. Anyway, we can conclude that the charge of this thing Fe is Fe3 plus, because we need the charge of 3 plus to neutralize the 3 negative charge, so this compound overall is a charge here. So the Fe3 iron is the iron 3 ion. So this is the case where we do have to use Roman numeral because iron forms many different cations. So putting all together, the name of this compound is iron 3 phosphate. So there you go. That is how to name ionic compound.